Hi everyone, so this is going to be the first video for Alkyne practice problems. I already posted 2 lecture videos going through addition reactions. So those were looking at adding halogens and then also reduction oxidation. In this video, we're just doing some practice problems related to those first 2 videos, which are linked below. All right, so for this first one, we can see that we have our functional group, which is this alkyne over here. And then we can see that our reagent is this D2, which is similar to hydrogen gas, but just the deuterium isotope. And we're using Lindlar's catalyst. And so Lindlar's catalyst reduces alkynes to an alkene. And specifically, we're doing cis or syn addition of those 2 hydrogens. And so what we should end up with is something like this. So we should have this alkene here, and the deuteriums that are added should be on the same side here. And so we should get this product here. And it's important to put those deuteriums in because those aren't the same as hydrogens. And so within skeletal notation, you do have to write in those deuteriums. All right, for this next one, we can see that we have also our starting alkyne, and then we're doing an oxidation reaction based off these reagents here. And so here we know that the first thing we want to do with an oxidation reaction is determine if we have a terminal or an internal alkyne. And so here we have a terminal. And so that means we will be selective and we'll only have one product. And so next, for the oxidation reagent, we determine what our product will look like. And so since we're doing hydroboration oxidation, we want to end up with the aldehyde product. And I'll draw in that enol that we'll get first. So here, the first part of the reaction will be this, and then that will be converted to the aldehyde as the final product. And so here, this will be our final product for this reaction here. All right, next we have, same as before, we have an alkyne, and here we're doing a hydrohalogenation, and we have excess amounts, meaning that we're going to end up adding in multiple of those bromines and those hydrogens. And so we're going to go all the way down to the alkane. And then here we have to figure out where we're putting those bromines. And so we know that this reaction goes through that carbocation intermediate. And so that bromine is going to go to the more stable or the more substituted carbon within the alkyne, which is that left one. And so this will be our final product here. And then I didn't draw in those hydrogens yet, but technically those hydrogens are going to be added to that terminal carbon. And then we have that one starting one. And so all together we added 2 bromines and 2 hydrogens to both carbons of that alkyne. All right, next we have H2SO4 with that mercury reagent. And so this is also an oxidation reaction. And so whenever we're doing an oxidation reaction, we want to determine if we have a terminal or an internal alkyne. And so here we have an internal alkyne here. And so since this is an internal one, that means we're going to have 2 products, regardless of which oxidation reaction we're following. And so we're going to end up having 2 products where both carbons will have a ketone. And one thing I really recommend with working with alkynes is counting the number of carbons that you have within this chain. And so here we can see that we have 4 carbons in that starting one. And so I'm going to draw out 4 carbons within our final product. And those middle 2 carbons are going to have a ketone within those 2 products. And so our final reaction or products should look something like this. And for this one, I didn't draw the enol form. I just drew like the final product that you would get. And again, note that you get a mixture of 2 products here because you have an internal alkyne, which is equally substituted. All right, next we also have same reagent as above, an oxidation. And so our first step for that is determining internal or terminal alkyne. And so here we can see we have a terminal alkyne. And so that means we will be selective and we will have 1 product. And so to draw that final reaction or product, we would get something like this. And so for this one, I'll draw out the enol just so we can practice that here. And so we'll have an internal alcohol. It'll go on that middle carbon there. And so then for the final product, it will be converted to the ketone. And note the difference between this one and the hydroboration oxidation reaction that we did above. Here, we're getting a ketone. In this previous one up here, we got an aldehyde. And that's because we use hydroboration oxidation for this top one here. All right, finally, actually we have two more. So in this one, we're looking at adding Br2. And I didn't put excess here, but we can assume that we have an excess amount unless it's specified that it's one equivalent. And so since it's an excess amount, then we would get full halogenation where each of those carbons is going to get 2 bromines. And then I drew in the hydrogen here that was initially on that alkyne, but you don't need to. You could just draw out those bromines. If you only had one addition, so let's say that it was Br2 with one equivalent, then the product would be this, where you just get a bromine to each of those carbons. And note that I put those anti to each other because Br2 addition goes through that bridged polonium ion, and so we get anti addition. But that's only if we had one equivalent. If we have excess, then we just get full halogenation and don't have to worry about the stereochemistry. All right, for this last one, we have DBr, and so that's similar. We're going to behave similarly to HBr. And then we also have our alkyne. And so for our final products, those bromines are going to go to that internal carbon since it's more substituted. And so we'll have Br here, and then on that last carbon, we'll have a deuterium, another deuterium, and then a hydrogen. And similar to that other one, the reason that these go here is because this is the more substituted carbon out of the alkyne. All right, so that wraps up this video, and I'll see you in the next one.